Hello, guys. Welcome to Cheenta School of Statistics and Data Science.
Plan for today is to understand the sizes of infinite sets. So can you give an example of an infinite set? Very easy, right? Natural numbers, right? We have seen that. So we will define the sizes of infinite sets in terms of something called bijection. So I have asked you to revise about bijection. Can someone tell me the definition of bijection? What is a bijection? One to one and on to. Okay. So one to one is called injective maps. Non to is called surjective. So in some sense geometrically, if we have these three elements here, each element is a one-to-one output, right? So therefore, and also surjective. So if it covers, if there are numbers like this, if you have the numbers like this, extra elements in the codomain set, the range and the domain. If there are extra elements in this range and in range or domain codomain space, then is it called not it's injective but not surjective because it's not covering all of them. So if it covers all of them, then it's called bijective because you can see it's one to one and it's covering all of the elements in the range. So what is a bijective function? It's a one-to-one function and an onto function. It's a one-to-one map. Every element maps to one element, and it's surjective. It's covering all the ranges entirely equal to the codomain set. For example, if f from R to R, if it is a function, then f of x is equal to x is a bijective function because why? Why? Because you understand it's one-to-one. Every element has only one output, but also it's covering the entire real number space. But fx is equal to x square is not neither bijective not one to one because -1 and 1 both map to 1, and also x square can only take positive values, so does not take negative values. So therefore fx is equal to x square is a non bijective map, but x is equal to x is a bijective map based on these two sets, right? All of you understood this? Yes or no? Just a small revision. Yes or no? Write in the comment box. Okay, thank you. Great. If any point of time you have some doubt, guys, please raise your hand and ask me your doubt. Okay, you're totally okay with it. Okay, so this is bijection. So how do you define it? So one way understand, if you want to compare this set number of elements with this certain number of elements, understand that if there's a bijective relation between these two sets, their number of elements will be same. So we say that mod A is equal to mod B if there are two sets, mod A and mod B, if there exists a bijection between A and B. So that means if there is a so f is a function from A to B and f is bijective, that implies that A, number of elements of A is equal to number of elements of B. All of you understood this definition? This definition is very crucial. So one example to, you know, one interesting property is that if F is bijective to G and G is bijective to H, then it implies that F must be bijective to H. Okay. If F is bijective to G and G is bijective to H, that implies that F must be bijective to H because of the inverse property. Like, you understand, this is intuitive, right? All of you understood this basic idea. If F is bijective to G and G is bijective to H, then F must be bijective to H. So you can learn more about this. So therefore, this is very important property. Okay. I hope all of you understood this. Yes or no? Great. Super. Thank you for your answers. So now the simple, let's take some simple examples, okay? First example. So this set, natural number set, is bijective to the integer set. Can someone prove it? So this is for what you have to do. To prove that, you have to find a function from natural number set to the integer set, such that, like, and show that it's 1 1 and 1 1 and surjective. Can someone tell me how to do that? How to find a function from natural number set to the integer set, like bijective function? So here is 1, 2, 3, 4. You have to find a bijection too. So prove that they're bijective. That any idea?
We can take two functions and prove that, like, if it has the same image,
Mm-hmm.
so we can prove that both the functions are same only, because so that it is only 1 to 1.
No, but you have to define a very specific map, a very specific function. Like where will x go? How do you define that? So let's say here is 0, 1, 2, 3, 4, 5, minus 1, minus 2, minus 3. So what if we define like this? The first step we go here and then we go here. So this is the first step. And then the next one we go here, and the next one we go here, and the next one we go here, and the next one we go here. So therefore it's sequential, So how do you define that? Understand. For f of n, so it's going from, so we have to define a function of natural number set. This is number 1 element. This is number 2 element. This is number 3 element. See the arrow. This is the dynamics. Okay. So therefore for 0, for 1 it's 0. N equal to 1 it's 0. For n equal to 2 it's 1. For n equal to 3 it's minus 1. For n equal to 4 it's 2. For n equal to 5 it's minus 2. You see this 4 to 5 is minus 2, 2, 3 is 1 minus 1, right? So understand how can you define this? If you divide by 2, n by 2, right? If you divide n by 2, you see you will get 1. If you divide n by 3, well, like 3 by, okay, if you divide 2 by 2, you will get 1. You will get 3 by 2. If you take the integer part of it, it's 1, right? But it's minus. So how can you define it? Understand. It's very simple. You can define it like, I will take this on that side. Now see, you can define it as n by 2, uska box, floor function. Okay. And for odd, it's minus 1 coming, for even it's 1 coming. So minus 1 whole to the power n into box of n by 2. Does it make sense, guys? Or do you want it to want me to explain it once more? You can ask me to explain it once more. So I can say that for n equal to even, let's say for n equal to even, let's say n equal to 2, we get minus 1 whole to the power n, like that's even, that is 1, n by 2. For n equal to odd, we are getting n minus 1 by 2. Does it make sense now? Essentially, this is what I am meaning. For n, we are getting, for n even, let's say 2, we are getting 1. For 4, we are getting 2. For 6, we are getting 3. For 8, we are getting 4. For odd, we are getting, for 1, we are getting, so for odd, see, we are subtracting 1. For 1, we are getting 0. For 3, we are getting, so here it is not this, but it's minus of this. For 3, you're getting minus 1. For 5, you're getting minus 2. That means you're subtracting 1 from the odd number, dividing by 2, and subtracting, like in multiplying by minus 1. Does it make sense, guys? This one? Yes or no? This movement, this pattern, does it make sense? All of you? If no, please raise your hand. I will explain it to you and tell me where it's your doubt. It's okay. For n it's odd, for any even it's n by 2, for n equal to odd it's minus n minus 1 by 2.
To book a trial class for your preparation courses of IITJM MS, ISIM STAT, and CMI MS Data Science, check out the first link in the description below. If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Let's enjoy the rest of the video. Stay tuned and stay blessed.
Prove that. So therefore, what do we get here? So therefore, we get the natural numbers have the same is bijected to the integers. So what do we get? We get that therefore natural number set is actually have the same number of elements as number of the integer set. The idea is very simple. Since it's infinity, if you can count in some way, that's only happens. If you count it in a countable integer type way. Integer means what? 1, 2, you're counting like this. This is 1, this is 2, this is 3, this is 4, this is 5. You're counting like this, right? For natural numbers. For integers, why it's that? Because you can count it in a similar way. You can see you can start with 0, then go to 1, then go to minus 1, then again go to 2, then go to minus 2. There's a sequential idea in that. So wherever there's a sequential idea of counting, that is usually, 1 to 1, or that's bijective with the natural numbers. So we will see this coming up in the sequences. A sequence is nothing but a function from the natural number set to the real number set. It will not be bijective, but it will be a 1-to-1 function. Not a 1-to-1, like it will be, not a surjective function. Yeah.
We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA. Our mission is to help you curve your career in statistics, data science, and machine learning. How do we do that? Number one, we help you build your foundations. We achieve that by making an optimized plan for your learning journey. Number two, we help you prepare and ace your entrance examinations in statistics and data science, like IIT MS, ISIM STAT, and CMI MSc Data Science. Number three, we give our absolute best to help you design your career by organizing workshops and certified data science courses.